So this is my first video. I'm going to be explaining everything I've learned so far. So I started off learning the basics of blockchain because I need to understand what exactly the blockchain entails. I go into smart contracts. So before we understand what a blockchain is, we have to first of all, I try to understand the old money system and how it worked. So let's say you want to send money. You open a bank account at a bank, and you want to send money. So for every single money you send from person A to person B has to be recorded. You have to record every transaction. So they have like a book where they record every transaction, everybody's balance and everything, so that they can easily remember, or maybe you want to send money another time, they can easily check your balance from the ledger and know if you have enough to send. You understand? So that's basically how they work. So this is called a ledger. So that is how they record it. Now they have a central body, let's say the manager or the owner of the bank, and this person has to validate each transaction. If you want to send money from person A to person B, the owner of this bank has to check his ledger. Do you have enough money? Do you meet the requirements and everything before they can be able to approve your transaction? But sometimes this central body, this is called the central body. Sometimes this central body or this owner of the bank can deny you or can refuse to carry out a transaction, maybe for whatever reason. Maybe you have an issue with the government or something and they block all your accounts. This person will refuse to carry out the transaction for external reasons. Now this is the problem with the banking system. It's because of the fact that this person can do something to your account, can block or prevent your account, or has control over your money. So this central body is the problem. And secondly, before you open an account, you have to link your personal reward data to that account, meaning you are not anonymous. They know exactly who you are, where you live, every detail about you. That is why when a government or an external organization notifies the bank they have a problem with you, they can easily freeze your account or prevent you from performing any transaction. So this is basically the problem with the traditional banking system. So for years they have been trying to propose solutions to this problem. We're going to get to that, and we're going to get to how blockchain is a solution. So before the existence of blockchain in the computer system, there's a problem they have. They call it the Byzantine generals problem. So this is basically like, okay, if the problem we have with the bank is like one person, what if we have multiple persons being the validator so that they cannot be biased? For instance, there's a problem for that same particular solution. It's just like we want to now have let's say 4 people now being the validator, so that if this person refuses, this person can accept or something like that. But this brings up a problem, a Byzantine general problem, meaning if these 4 persons are to make a decision, these 4 persons are mutually equal. Let's say they are all the Byzantine's problem generally is like we have 4 generals in a war, and let's say the war, for that war to be successful, each of them has to strike at the same time. but they are not together. They are at different locations. So how do we pass an information across? And for each of them to relay an information, they have to pass it through a messenger. Let's say this person will have to send a messenger to 1, 2, 3. Let's say this person will have to send a messenger to 1, 2, 3. This person will have to send to 1, 2, 3, that kind of stuff. So how do we trust that what this person is sending, or this person that says attack, how do we trust that is not lying? How do we trust that this person has not collided with the enemy? And then they will say attack. If 3 of them attacks, the war will not go, will not be in their favor, they will lose. So it's basically like if 4 people have to make mutual if 4 people has to make mutual agreement without seeing each other or by passing a message, and 4 of them are generally equal. How do they do that? That is the Byzantine general problem. So before the existence of blockchain, this has been a problem in I think computer science. So they have a solution. They call it um, the BFT solution. They call it the BFT solution or the BFT consensus. So this is like a family of different solutions for this Byzantine general problem. So a popular example is the PBFT, which is the practical Byzantine's fault tolerance. It's just like let me briefly explain. In this case, let me use figureheads to try to depict it. So you can have, let's say we have general 1, general 2, general 3, general 4, and general 5. Let's say these are 5 people who are they have equal powers, or they have equal ranks to make a decision, and they're not together. Maybe they're in different parts of the world. So let me try to explain the practical Byzantine's fault tolerance. Now they will have to go into voting. Now this is possible because we know there are 2 things about this solution. It works because 1, we have a fixed number of voters or of decision makers, and that is it. Because we know the number of, that is why it can work. So these people have to vote. They have to vote, and the voting is done in 2 rounds: the first round and the second round. So the first round is basically like they have to vote on something. Let's say this person now broadcasts a message that okay, we will attack now. Broadcast it to everybody. We're going to attack now. 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 Now they have to vote. Everybody has to vote and tell everybody what they heard. So this person now is going to broadcast his own message. I heard. Are we going to attack now? Attack now. Everybody answers this question. Attack now. So this person sends out. Let's say they send out yes. This person sends out yes. This person sends out yes. Let's say this person is a false general. He has like an affiliate with the enemy. He's going to send out no. This person can send out yes. Now everybody sends out what they heard. So obviously this person broadcasted, are we attacking now? We are attacking now. We are attacking now. We are attacking now. We are attacking now. This is the first broadcast. So the first voting session is going to be an answer to this. So everybody is going to broadcast what they heard. So this person is going to send yes to everybody. This is what I heard. This person is going to send yes to everybody. This is what I heard. This person is going to do the same to everybody. And then this person is going to do the same, broadcast what they heard. So now basically everybody has what each of them has broadcasted and heard. So this person now is going to have a record of 1, 2, 3, 4. 4 persons going to have a record of yes, yes, no, plus the initial proposer, yes, and his own. This person too is going to have the same combination. Yes, yes, this person, same combination. Yes, yes, no, yes, yes. This person, yes, yes, no, yes, yes. This person, yes, yes, no, yes, yes. Now, each of them now has the same. Remember, they are not seeing each other, so they are basically sending messages. But each of them now has the same combination. Now they are going to check it against. There's a rule. I think 3f plus 1 has to be less than or equal to something. I don't want to go into. I don't want to bore you with the details. So it's basically like they have to check if 2/3 of the votes are saying the same thing. So obviously from this combination, you can see that 2/3 of this vote are saying yes. Like basically the majority are saying yes. So everybody will now go with attack now. Yes. That is round 1 of the voting. Now round 2 of the voting is after everybody has checked against the 2/3 rule and everybody is now seeing that okay, even this person, the false what's it called, the false person, everybody has seen that okay, yes, the majority is yes, the majority is yes, the majority is yes. Now for this voting session to now be concluded, everybody still has to broadcast to everybody that we are all choosing. So the next message they're going to send is we are all choosing to attack now, or we have concluded on yes, something like that. So everybody now is going to send this message to each of them so that everybody will know that everybody is on the same page. So this person is going to send we are using yes, we are using yes, we are using yes, we are using yes. This person too, we are choosing yes, we are choosing yes, we are choosing yes, we are choosing yes. Same thing goes for everybody. So now the second one is basically a declaration of what the entire group has finalized on. So that's basically how the Byzantine general problem was solved. This was before the invention of blockchain. So now let's go over to blockchain and how exactly all these things matter in the blockchain space. Now, just like we knew just like we had a bank where this is a bank and one person is this is the bank ledger, the bank's ledger. That's the book where they write every stuff, every transaction, and one person is the central body. Now this is the normal traditional system. Now for blockchain, it's just like now they don't want to have just one central body. They want to have multiple bodies, multiple people, or multiple computers doing the checking. But prior to this, obviously blockchain makes use of digital currency. Digital currency basically is money that is online, understand? But the problem with money that is online, so let's go back to digital currency first before going to blockchain. So the problem with money that is online is the fact that in physical cash, if this is Mr. A and this is Mr. B, this is A and B. Physical cash, if Mr. A has money and he gives it to Mr. B, once you give it to Mr. B, you can see that Mr. A will no longer have that cash because literally, in reality, if you give somebody something, you cease to have it. But in a digital currency, if it's a digital currency, let's say, for instance, a picture, if you have a picture on your phone and if you have a picture on your phone and you send it to this person and you send it to person B, this person now has a copy of that picture. You still have a copy of your picture, you understand? So that same thing happens for currency. In digital currency, when you have money and you send it to another person, both of you still has a copies of it. So this particular issue now is what they call the double spend problem. This is a problem that is gotten from having a digital currency. So before blockchain, they had one digital currency they call DigiCash. I think DigiCash. So because of this double spend problem, you still have to have somebody in the middle checking whether okay, oh, the money this person sent to this person, after sending it, this person no longer has that money. So this still has you still have a central body. So the central body checking all this digital transaction is because of this double spend problem. That is why you must still have a central body checking it. You cannot, even though you have like code running and everything, you have to have a central body to prevent this double spend problem. Because some might argue that okay, why not just set up a code that records transaction on its own, and you will still have this double spend problem. So that is why you still need somebody to check to validate it. So now blockchain, this all these problems have been existing before the before the inception or the origin of before the arrival of blockchain, or before somebody proposed blockchain as a solution. So now let's go to blockchain. Now, since we have a central body, in this case, this is the person that is checking or recording this transaction. In blockchain, what if we have several people who are doing the same thing? Now, you have several persons or several central bodies. Now, if you have multiple people, let's say they're up to 500, for instance. If you have 500 people, if this person refuses to grant a transaction, you can obviously move to the next person. The person refuses, this person can grant. So the idea is like all of them are mutually equal. They're like the same, they have the same power to grant or to record a transaction for you, unlike one person. But now you can have a problem of that Byzantine's problem. And what if all of them still agrees to deny you access or to refuse to record a transaction? That is still a problem, because if one person can deny you, obviously if a group of people agrees unanimously, they can also deny your access to perform a transaction. So now let me basically explain what blockchain is and how it solved all these problems. So now, first of all, there are two characteristics of blockchain. Number one, in a banking system, when you want to open an account, you have to bring all your reward data. For blockchain, that's not existing. So number one, you are um, so the first thing is you are pseudonymous. I don't know if I got the spelling right, but you're pseudonymous. So for now, let's just assume you know the word pseudonymous. Let's just assume pseudonymous means anonymous. Nobody knows you. When you are creating an account in the blockchain space or something, nobody knows you. You just have an ID, which is like they call it private key. I'm going to explain what pseudonymous means later. So you are basically opening an account with private key. So it basically means that in the real world, or if a transaction comes in, nobody knows you. These people, these 300 central bodies, they don't know you because they are only seeing your private key, so they cannot be biased. If you have a problem with the government, they will first of all have to go and find your private key, which you can hide. Understand? Now, secondly, it's not centralized. Like we said, why can't the 500 of them just collide and decide to block your account? That's the thing. Secondly, it is not centralized. I'm going to explain why it is not centralized. It is not centralized. By not being centralized, I mean it doesn't have one central body. Now, for this kind of situation, for you to be a bank manager, to be a bank owner, CBN has to give you has to approve your, or have to be like a supervisor. They have to vet your bank and all this kind of stuff. So basically, there's a body that chose if you can be a bank or not. Now, for the blockchain system, it is not centralized, meaning there is no particular select group of people that are chosen to be, let's call them validators, like people that choose whether a transaction can go through or not. So anybody can be a validator. Even you listening to this, you can be a validator. It's just like you saying you can be a bank owner or a bank manager. So they have a network of validators all over the world. They have a lot of validators all over the world, and we call this individual. These are like people's computers, obviously. So these are people computers. We call it nodes. Now you see this ledger. Instead of having one ledger, we have a shared ledger or multiple copies of the same ledger. So every node has a ledger. Have the same ledger. Is this particular single ledger now is distributed across all nodes, so each of them have the same ledger, is the same copy. That is why it's number one, it is no longer centralized, because anybody can be a node. Everybody can be a node. If you have a system and you want to be a validator, you can join into the network and start validating. So you can't have the problem of everybody colliding. That's one. Two, nobody knows you, so nobody gives a fuck about you. If this is you have a problem and you have a problem with the government or they want to freeze your account, you're only performing transaction via using a private key. So if your transaction comes in, let's say send 1 BTC to a person, they don't know you. They just have your private key. Your private key as the authorization or something. So if you try this person, if you bring the transaction, first of all, this is your transaction. This transaction gets broadcasted to every single node. This is called a gossip. So now, how this transaction is then broadcasted to every single node. Now, the question you might be asking is, okay, if everybody has the same copy of the same node, how do they maintain consistency across all the node? Like, how do they now maintain it? Is it that once I update this one will be updated? No. If each of the individual nodes will have to still update their copy by themselves, but somehow all of them are in the same line. Now let me explain where the word blockchain comes in from. Remember this ledger we talked about is how the word blockchain comes in. So let me get to that. So from the word blockchain is just a chain of blocks. What is this block? This block is like a ledger. So a chain of multiple ledgers. Now this is how it works. You see this shared ledger, it comes in blocks. So I'm going to make another video explaining how this works out. So this is a ledger. They will pack in transactions, records of transactions. They will seal it to something called a hash. Now this hash links this to the next block. So when they have a particular amount of transaction they can record in a ledger, they call it block. They'll have to create another block. This block will have another set of transactions written on a hash. Now this hash points to the previous one and to the next one. So they can be able to chain. That's how they work. So they have a chain of different blocks. Each block is sealed by a hash and contains transaction, just the same way you have this. But now this has a seal. It's like a cover or something, an official stamp. It has. So that's what a hash means. So now each of these individual nodes or computers has this chain. So how it works is, for as we progress, you see how they create this stuff. So how it works is, if there is a new block, everybody adds it to their own chain. When a block is formed, we are going to talk about when a block, how do we form a block. So that is how they keep adding blocks and adding blocks and adding blocks, and everybody does the same thing. So the problem now is solved. The problem of not being able to freeze your account and stuff, because we obviously have different nodes. Today we can have 300 nodes. Tomorrow we can have 500 nodes. Nobody cares. Nobody knows who you are. What they do is they just check. Once you want to initiate a transaction, they just check, does this transaction follow the rules, like to prevent the double spend problem and other things, or do you have a balance or stuff like that. So they just check. So now the only thing that we don't understand here is that Byzantines, because obviously we have the same Byzantine system here, but we have different individuals making it, trying to be the different individuals with equal powers making a decision. So the only problem now that you can visibly see is the Byzantines problem, which we are going to talk about when we explain how exactly they maintain consistency across all nodes to have a blockchain. So that's basically it.